make sure this is. Do you guys care what that thing is like in there? Does that little, do you guys even pay attention to this little screen when you watch these videos? There's no. All right, so we're live now. Now, what I want to do is first talk about the test. Are there any questions, any problems you would like me to do, things you didn't understand? I'll put up the test and the solutions when I get a chance. I'll put it in Blackboard so that you'll have them. No, you didn't. Matter of fact, I'll probably make up some while we're in class. So, any questions on this thing? Well, feel free. I usually save some time for. I usually save some time for questions if you want. Oh. Yeah, take a look at it.
Okay. 6.
6 feet? All right. Take a non-marker. Did they take my writing device? Isn't that right? They took it. Okay, all these thicknesses. These little tabs are incredibly memory intensive, so I have to, can't have too many of them up. All right, this here portion means you can cross multiply it. Remember this guy? And it's this down here. And this guy times this guy. Or the cross multiplication. And then from here, you approach it like anything else. I'll go ahead and multiply the 9 through. 45x minus 18 equals -8. We go there. None of your faces looks like you're going, Ah, yeah, I remember that. It's like I'm showing you for the first time. You get a whole section on proportions. All right, what would you do from this stage? Add 18 both sides, I get 10 equals 45x. Finish it off by dividing by 45. I don't know, it said to simplify these, didn't it?
Yeah.
Can that be simplified at all?
Five.
By 5. You can cancel out the 5. 5 goes into 10 twice. 45 goes into, I goes into 45 9 times, so we end up with x is equal to 2/9.
Okay, when you did this, so you were just minusing points. When you did it.
Right, exactly.
Oh,
If you get a problem, if it doesn't say -5, you got some partial credit. Because these were each worth 5 points. Other question.
Start with eight.
What number did you say?
Eight.
Eight?
Same thing.
Okay. While something is in my brain, I wanted to tell you about it. Before I do this problem. Let me come back up to where we were. I want to show you guys something that you can use as a reference now. Let's see if I put it in there. Well, all right, I guess I didn't put them in here just yet. I have made videos, full-length lectures for this material for the rest of the course.
Eight was it. I think you got them.
Are they in there somewhere? Where?
Well, it shows your video.
Well, I'll put it up. It's not a big deal. It's in their YouTube videos. What happened is 4 years ago, COVID hit right at this time of the semester. And so everything shut down. So I had to make videos to you. So they'll be available to you. It'll be very helpful. If you have, like, if you leave here and don't understand something, you can watch the video. It's too bad I can't find it. I know, I think I showed it to you, but for some reason I just can't, don't see a spot over here for it. Actually, I'll probably get it done before the test today. Or before we leave today, I could probably get that done. I need a syllabus. Let's see what we are doing today. Today is 227 indeed. So linear equations in two variables and plotting points and finding intercepts. I think what we need here is some specialty paper. Let me see if I have any. I have graphing paper. If you have graphing paper, feel free to use it. Straight edges like rulers. Have you guys got any of that?
No,
Is that your bag behind you?
yes.
Okay, I put a test down there like that person showed up. Let me give you some graph paper. One thing that makes math a difficult subject for people is the precision that's required. And you don't go around being as precise as math requires you to be. Is there a ruler? Where are my rulers? Look at my rulers. Does anybody need a ruler? Need that, huh? These are not yet.
Okay.
How hard I had to get down with the bar to provide me these things? Oh, there's more there, okay. Well, I think in here, I'm gonna sort of mash 4.1 and 4.2 together into one lecture. Let me pop back here. I'm gonna change the look of this then. And I can change the look. I'll show you in a minute. My view, we can do. What's that?
That's the first.
Oh, thanks. I don't know if I can make that show up any better than that. But what I'm going to do here is kind of remind you of something you've almost certainly seen in the past. I think it's in this menu here. I like to get a little ruler. That's really cool. I don't know what that thing is. I don't know why it puts that there. Oh, I see. I want to do three-dimensional. That was my bad. It's been a while since I've been in here. You guys ever seen anything like this before? You've seen it, right? You call it a graph. There's all sorts of different names it goes by. My favorite is Cartesian coordinate system, after Rene Descartes. Well, then you probably, let me add to this some detail. You're probably familiar with it being labeled like such. Am I correct? Yeah. And in fact, this, we gotta make sure we have our direction, because it's hard enough when we do the inequalities to know left and right. Now we're going to have up and down. So this is two-dimensional in nature. This, anybody remember what this horizontal line is called? The x-axis. The x-axis, that's right. And never guess what the other one's called. The y, that's right. So I didn't even write that down. You guys know it. Typically, you'll have numbers on those things. Like, that's weird. So if mark them, so I might go 1, 2, I'll do every other one so they can space it out. You should try to keep your lines along the grid pattern that you have on your paper. Now, when we're doing these graphs, please don't throw multiple graphs onto one. Just do one problem at a time on them so you can follow it later. All right, first thing you're introduced to are something called points. They're in this form, x, comma, y. They call it an ordered pair in that it matters which one comes first and which one comes second. So the x is first. The x is the horizontal direction, and the y is the vertical direction. Well, let me throw up the first thing I'm going to do. Plotting that means that you're going to put them on a graph. I'll sort of get a feeling for this. Has anybody in here played Battleship? Well played it? So you know how, what you guys know, you say A5, right? A is the location, vertical or horizontal, and 5 tells you which other way to go. So if you played that, this is pretty natural. Let me put some other numbers here too. 1, 3, 5, 7. So let's start with 1 in this area here. Let me do
9, comma 1. So the way it works is you can go to x equals 9 on the horizontal axis. So here I go to the right 9 places, and then what do I do to get to the spot here that I want? So 9, 1 is this location here, 9 here, 1 up. 9 to the right, 1 up. And all you gotta do is put a dot here. And it is plugged. You with me? This concept is never a difficult one for students. Where do you think the location of that one would be? I mean, so here's how I always do it. I pretend like I'm starting right here at the center of this intersection. You tell me which directions to go to get to that location.
Which one? The 9 and the
The next, no, we already did that one. The -5 and the 4. The first one is horizontal, that's left or right. To the left, 5 places. All right, now, the second one tells you how to go up or down. How much, where should I go then? Up 4. So I go to the left 5 and I go up 4. That's where I put my dot. So negative corresponds to left or down if it's in the second spot. Let me put one, let me do, -3, comma, -6. And you only label as much as necessary. So I'm gonna start from the same place, and I want you to tell me, I'm gonna start from here. Does anybody know what this place is called? 0, 0. It is 0, 0, but it's also called the origin. If I have my finger at the origin, tell me how to get to -3, -6, using words like left and up, right and down, etc. So starting here, which way should I go? Do left or right first.
Oh,
Follow the order. Which should I do first?
-3,
Go to the left 3, now what?
come down -6.
Go down 6. So left 3 and down 6. I put 1 point. Let's do something in that area there. So I'm gonna do, my next one will be 7, comma, -3. So explain to me how, starting in the middle, how I would get to that point.
I'll go right 7
Go right to 7,
and down to -3.
down to 3, that's -3, right? So we have a little practice here. We throw a little other ones on here. These ones will be oddities maybe. This one here is 7, comma, 0. Tell me how to get there.
So we start with 7 and go to the left to the, in the middle.
No. The 7 tells you which way, left or right. 7 tells you left.
It's right,
Positive 7 tells you right.
right,
So I go to 7,
and then up to the 0 in the middle.
can't do anything, good. 0 means not going anywhere. So it's on the axis itself. So that's that one, you just had to go 7 to the right. It fixed my 0, made it look really nice. Tell me how you get to 0, 5. Starting at the center, where would you go to get to 0, 5?
0 to the right to 5.
No, you're missing the big thing. The first one is left or right. Do I go left or right?
You know, from 0 to start.
Means you don't go anywhere. So, and then, so what if you don't go left or right, then what do?
You positive.
Go to up, 5, starting at the origin, don't go left or right, stay where you're at, and then just go up here. So there are a few more of these in there. Likewise, I can get one here and here. I can do, -5, comma 0. That'll be this guy right here.
You go to the left for -5.
Right, so left 5 units. And then we finish off the bottom. We'll do 0, comma, -5. Just like that, so it's supposed to be -5. So where, how do we get to that thing?
You can go all the way to negative. You will start in the middle and come down to negative.
That's right. So when you use words, try to use words like left or right, up and down, be specific. Instead of over, words that are not as descriptive. And then finally, last one in here, what's the location of this column? You said before? 0, 0. Oh, that's. Fix it by right. Okay, so. That's called the origin, there's another term for it. So getting our way around is sort of what we're going to do, but there's more to it than that. We're going to be graphing things on here. We're going to be graphing straight lines, straight line flat, right? That's what the rulers are for. Did I get into, I don't remember, I didn't get in there yet, did I? No, I didn't. Okay, I thought it was in Alex. Four point one. I'm interested, what we're gonna be doing is working things like this. So that's what I'm gonna go right into and see if they have anything. If not, I can make up something real quick. Okay, good. These are what I'm looking for. All right, what's gonna happen is you're gonna be given a bunch of equations and you're gonna be expected to use it to, graph. I'll show you what I'm talking about. Let me see if I can make this bigger so that thing will fit on the page. There's 62. This is the gist of what we're gonna be doing in this section, plotting these things on that paper. So let's grab this guy here. So there's two components here. We've got this table of values, but we also have this here, this equation is the rule that it has to follow. So if you look, this table says when x is equal to 0, would you possibly be able to tell me what y is equal? X is 0, so what should you do with that 0?
So it equals 4.
Right, you should plug that 0 in for x, right? Then you'll get y is equal to 4, so this blank spot will be 4. Let me go ahead and write this up. So when x is 0, that's this case right here. Let's plug it in. Y is equal to -3 times the 0 plus 4. So I've substituted it in. So you can pick the number that you want to use for X, but then Y will be determined by the rule. Try the next one. Suppose Y equals 0 instead. Could you tell me what X would have had to have been? Here, next, we have the next, so it's Y
4/3.
right, so you're gonna have the equation then, the equation will look like 0 equals -3x plus 4. And then to solve this, first thing you would do is add 3. 3x. And I'm ready to finish it off by dividing by. Now, this would be a difficult thing to graph because our graphs, you know, you don't, how do I want to put it? On graphs, you can't graph that stuff. So, all numbers, integers you can do.
Don't you subtract 4 first?
Well, I just wanted to get the x on one side. Okay. You could, it would have been the same either way.
Okay.
I guess it must be like this. So want to avoid the negative, I did it that way. Now for the next one, then we have y equals -2. So that means my equation becomes 0 equals -3. This is -2. Y is -2. Now here, I would definitely subtract the 4 first. Because I'm gonna leave the x's on the right.
Here on X equals 2.
Let's find out, let's see, subtract, yeah, I think you're right. -4, -3x equals -6. Divided by -3, divided by -3, 2 equals x. Now, when you plugging in x is really easy because you can just read off what y is gonna be when you know the value of x. Here, you know, x is equal to -1. So then y, the equation for y is y equals -3 times -1 plus 4, and that looks like 7. Now, the numbers that they have there were chosen for you. In practice, you can choose whatever number you want. Let me graph this thing to show you what it looks like. Now we're gonna graph those things we just did. So from that table, we're gonna make a graph out of it. Usually I'll do X, Y on these, but maybe I will when I get over there. But what I'm gonna do on this graph, I'm gonna graph 0, 4. I can't really do 4/3 0, but these other 3 I can. And I want you to see something. So here's how I do it. Using this thing to make a dot, I need to make this a little bit bigger. And then I think those are appropriate for me. So 0, 4, tell me how to get there on the graph. 0, 4.
No,
So what do I do then? How do I, from the middle, where do I go? How do I get there?
just up 4.
Just up 4. So I have 1, 2, 3, 4. Let's see if this dot is big enough for me. Is that adequate for you, that dot? Okay, next, like I said, I can't do 4/3 because I'm not going to try to estimate 1/3 of the way over.
That's, but I will graph these other two. So 2, -2. Tell me how to get to 2, -2. There I am in the middle.
You said 2, -2.
2, -2. Yes, I'm graphing this down here. Tell me how I get there.
So you go right to 2,
Uh-huh.
and you come down to -2.
All right, that's, and make sure you get it right on that corner spot too. You want to be precise in these. Now, watch when I graph this last one. This is -1, 7. So tell me, if I'm here at the origin, tell me how I get to -1, 7.
You go left to -1
Uh-huh.
and then up to 7.
Here's what, 4, 5, 6, 7. Now look at the dots. Do they look like they line up?
Yeah.
You can easily test yourself to see if they do line up. Back here. I'm gonna draw a line through them. They have a ruler here. I never tried this one. Put it in. I think I can angle around there. Serious. This may not be any good for me. I always learn how to use it. Probably
Try
start.
rolling the middle one.
Hey, good job. Let's move it over.
Is it?
Looks like
Good
it.
to me.
Would you say those line up? And so what I can do, it lets me do this. I can draw, but I need to change my pencil size to 2 smaller. And I believe it lets me draw along here. And you can see it certainly lines up, doesn't it? So the idea is this. Have you ever heard the phrase 2 points determine a line? You've heard this, what about the shortest distance between 2 points is a straight line? You've heard that one. So these, what you're gonna do when you have them at the end, see if they line up. Then you'll know that you did it correctly because all the equation we know is correct. All right, so let me give you one to try then. I want you to do just like I did, graph the points, then see if you can draw a line through them. See, they give you the equation right here. Let me give you something like that one there, 66. So first, as I mentioned, fill in the table. And then plot, they call it plotting if you graph it, so plot the graph.
So we don't place the -2/3.
You can't graph that. Now, there's ways around it. I'll explain that in a minute. When you're done, I've already put up the dots, make sure yours looks like mine. They certainly look like they line up on my picture. You don't actually have to draw the line, they just want you to see if they line up. Yeah, we're back in here. I think I got it. They line up though. Now let me show you how to graph that 2, -2/3. I'll show you how you can do it. Has everybody got their points and everything? Can I move on? Okay. I want to get rid of that thing. I don't want it around anymore. And I need to change the pen size to normal. So, how do you graph? So how do you graph something like that? We're not gonna get into this, but I just want to show you how to get this way around it. We can change the scale. That's how we can do it. So let me draw another graph, but I'm gonna label it differently than I have before. Some space here. It's supposed to lock into the grid. All right, good. All right. Here's what I'm going to do to scale. See how I'm changing the scale? See how I change the scale? Now each mark is not one. It takes 3 marks to make up one. So therefore, could you tell me how much is each one of these little squares? How thick is it? A third. 1/3. That's how I get my thirds. So on this one, I wanted to do 2 -2/3. So let me get my numbers down here. Here's -1, -2. All right, so it says I want to go to 2 -2/3. So I'm going to go to the right 2, and then I'm going to go down 2/3. There's 1/3 and there's 2/3. So you can change the scale to do this. If I had fourths hanging around, I would make each 4 squares would make up one. We will not be doing stuff like that. It's, I just put it up there so you, because a lot of students, I never ask students on a test to graph a fraction. It's just, because I just want you to draw the lines that you're asked to do and be pretty straightforward, nothing ridiculous. So we'll do some more practice with that. Let me pop over to the next homework section. We'll do a bunch of these problems. This is when you're going to graph lines by plotting the points that we had and then connecting them with a straight line. So I'm not even about that. Let's go here. All right, so here, what you're going to do in this section is you're going to make up your own table. Okay? And you're going to choose your own values. So let me go ahead and pull myself out one of these things here. Show you what I'm talking about. That's not going to work for me. They said finding the intercepts and at least one other point. What do they mean by the intercepts? The intercepts are the places where it touches the x-axis or the y-axis. They call them the x-intercept, the y-intercept. So the way you find these intercepts is you got to keep this in mind. In one of these graphs, if I have a point on this graph, can you tell me for certain what one of the coordinates is going to be? But it's on the line. I don't care about that.
Or positive.
Let's say it's called. What about the y line? 0. See, the x and y intercepts are places where the other thing is 0. So this x-intercept here is where y is 0. So what you want to do is plug in y equals 0 and see what you get for x. But when y is equal to 0, this equation becomes 0 equals negative x plus 3. How would you solve that equation? X equals 3. X equals 3. It's very fast. I can add x to both sides. That means the number that goes over here is 3. Now, they also want you to use the y-intercept. So this time, use your logical thinking skills and tell me what would get the 0 this time. From any point up here is going to be 0 x on the y, right? Yeah. So on this next one, then I'm going to let x be equal to 0, and tell me what I get for y out of x. So if x is equal to 0, that means y is going to equal negative 0 plus 3. Anybody happen to know the value of negative 0? 0. Same as 0. This is equal to 3. Oh, nice. They have similar intercepts. So I'll put a dot. So when I know my graphing, I'll put dots both places. Let me go ahead and put this. I told you 2 points determine a line.
I was just gonna get E0 installed, E0.
Absolutely. Remember these points, I'm gonna go down here and make my graph. I don't want to keep this up. Get thing out of there. All right, I had 0, 3, and 3, 0. So let me go ahead and put those dots in. Can you tell me how to get to, I'm here now, tell me how to get to 0, 3.
0, comma,
That's right.
and then go up to 3.
Okay, then the other one was 3, 0. So tell me how to get there from here.
Start on the right with 3. Come down to.
Sorry, it's 3, 0. So tell me the,
Say
yeah, but what the point is, tell me how to get there from where I'm at on the screen. I'm right here in the middle. How do I get to 3, 0?
right to 3.
There, and stay there.
Stay.
Now technically, this is enough to get your graph. You can connect these points right now. The only thing is, you're not gonna know for certain if you are right by doing this. Now I can take a shape, I can just take these lines like this. They usually have arrows at the end of them. Oh, you know what else though? You gotta watch this, because if you don't pick the right thickness, it's gonna be this big fat line. I don't want that. I did not expect what it did. I can turn this. That's exactly what I wanted to do. Yeah, that. Now they line up, of course, any 2 points is gonna line up. How do we check ourselves? What do you need to do, you think? Anyone? And these, I've been drawing these kind of where they need to go right through the center of these things. Make them stop.
Check if, X equals 5.
Pick another number. So here, I think since X is already over here, if you pick any number, once you pick it and plug it in, you'll know immediately what Y is. So yeah, pick something for X. Why not choose just like 1?
Oh, well, because 5 was landed on the, -2, so.
You wanna see if it comes out? All right, we'll put a 5 here and see if we get a -2 for Y. I think you can see that that's going to happen, but
So X was gonna equal what, 5, you said?
Yeah.
So when you have that, you have Y then equals -5 plus 3, which is in fact -2, which is what we wanted. So that's a good check. You need the third one, you need a third point to check yourself.
just drawing the 2, I mean, you're always gonna be able to connect 2 points with a straight line. The third one is gonna tell you if you got it right. So let me go ahead and get that in. Five, -2. Yeah, my graphing was a little off, but you get the idea. Okay. Let me give you, that's an easy one. I'm gonna give you some more complicated ones than this. Let me know when are you guys all good now? Can I move on or?
There, shortwave graphics.
Well, that's the whole point, but you gotta have a good feel for it before we start throwing in the short cuttings.
Okay.
Right, they're not really short cuttings, it's just a faster, more efficient way of doing. Holy cow. So my recommendation to you, if you can do this, is to put zeros in for X and Y immediately, because that'll graph the intercepts. So X, Y. So when X is 0, what do you get for Y? You gotta replace X with 0. So that'll be 0 equals 5 fourths Y minus 5. How do you solve the equation?
It's easier to do Y 0 first.
It would be, yeah, sure. I figure I'd just get, I mean, you gotta do this one anyways. It's not like we get out of it. Yeah, it is what you do.
So, add 5.
Add 5.
5 equals 5 over 4Y.
Okay, we're almost there.
So, is it 20 over 40? It's 5.
So you're talking about multiplying by the reciprocal. The same as dividing by 5/4. But I think what you're trying to tell me is to multiply by 4/5.
Yeah.
Do it to both sides of them. How can I make this one compatible for this? For one of this, so we know we're dealing with a fraction. All right, and that's nice, the 5s do cancel, don't they? And over here, everything cancels except Y. So Y is equal to 4. We took care of the worst one first. Next, you could let Y be 0 and tell me what you get for X.
-5, or just 5. That's right.
-5. If you replace Y with 0, you get 5/4 times 0 minus 5.
Oh, okay, then. So you don't bring X over. I don't know.
Then Y equals 0. The equation will become X equals 5/4 times 0 minus 5.
So this equals -5.
Which equals -5, that's right. I think it was no space there, but I want, but so I've got 2 points. I want one more as a check. Let me go ahead and get my graph started here and then we'll see if we can come up with a checkpoint. The easiest thing, I'll tell you what, you want to make, there's a number you could choose that would be so useful to you, but you have to see it. Back here. All right, let me get those intercepts in first. Let's take a look here. Okay, 0, 4. Tell me how to get to 0, 4. So here I'm in the middle.
0 equals
Go to the right. No. 4 is in the second place. You don't go to the right 4.
go down.
Up 4.
Up 4.
just up 4, that's all you gotta do. They're really easy points to plot, so 1, 2, 3, 4. What isn't it? Back. All right, then the other one was what? -5, 0. So that's over here. No, left or right, it comes first.
Okay.
So go left 5. 1, 2, 3, 4, 5. I don't want to, I want to make it, I want to put it right on that edge. And now let me connect them with a line. That is way fatter than I wanted. Back 2, I think. Oh, kind of thick, isn't it? I guess I don't care if it's that thick. Anybody pick a third point? Give me a really, really, really good third point. You can use your mind. I would like it to be really nice. What could I use to be really nice here? It's easier. Did you notice it's easier to plug numbers in for Y? Because it's on the other side. Everything's on the other side. So if you plug in something for Y, you immediately get X. Give me something to plug in for Y that would be particularly good.
And you want the house, full screen up.
What's that?
You want everything to go. You can have them.
Yeah. Well, I want to check, I'm trying to check myself. I already got my line and everything. I need a third point here. Now look, I was going to choose 4 for Y. Do you see why I would choose 4 for Y? If Y is in there, it's 4. They would cancel. So you could do that. You could choose 4. Or one thing I could do is go to Y equals -4. You could do that. Or you could do Y equals 8. All those numbers are useful. You know what I'm saying? So if you can use those, very nice. So what I'm saying is this, I'm going to use Y equals 8. So I'm going to replace Y equals 8 here. And then I'm going to get 5 for X. I'm going to check that now, graph. So Y equals X, 8, 5 is X. So let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I got it there. Oh, that's still thick, okay. And a lot of times, if you draw a graph like that, where you just have those points, it's not a bad idea either to label the thing right there, or at least let somebody know this came from when X is 5. Y was equal to 8. Okay, so it checks, doesn't it? All 3 of them line up. Good. Should we try another? I don't think I've let you try one all the way. So let me give you one try. How are they giving that? I don't get it. I don't think it's okay. Where's the one I want? Okay, that'll.
Did anybody get this part done? I don't know. Right, so when you get, so 3 times 0 is 0, that goes away, so what do you get for y?
Yeah. 6.
Is it positive 6? Doesn't have a negative part?
So this is. We can,
Plus y. Plus y. Negative 16. What is y plus 0 equal to? So next line, y equals. So if you let x equal to 0, you should have got negative 6 for y. You guys get that? When y was equal to 0, what'd you get for x? 2. 2. Let me get this started. All right, so remind me how to get to 0. Negative 6. In the middle, here, tell me where to go.
come down to.
Come down 6 units, so 1, 2, 3, 4, 5, 6. The dot here. Next, then 2, 0, tell me how to get to that one.
2 to 2. Stay.
That's right, you stay there. Okay, now let's get our line through here.
Pretty sure.
That should be a negative 2, shouldn't it? Check it out. Negative 6 divided by 3 should be negative 2, shouldn't it? Are you guys with me?
Yeah.
If you allow, let me see, what is it, y equals 0?
Yeah.
3x equals negative 6 has negative 2 as a solution. So let me get that in there. So that changes that there. I'm not sure I'm gonna be able to make this work right here because if I go and erase that, it takes away the whole thing. All right, so I got a negative 6, 0, good. All right, this thing course is not right. See, I mean, it's supposed to lock into these grid things, right? But it doesn't always do that. All right, that should be fine. All right, so I got my 1 dot. Then negative 2, 0, how do I get to that one?
Negative 2. You come down to negative 2.
Come down to it? You gotta use left or right or up and down. That's not the left, 2 units to left, right, exactly. So there's my guy over there. The line is angled differently. Now I'll put my line through these. Did anybody have a checkpoint that they used?
Yeah.
What'd you use?
I used X equals 1, and then Y equals -9.
So it's on X equals 1. So this is one you get to invent yourself.
The zeros are smart business.
So we're gonna let X be equal to 1. Then when you put that in, and X is equal to 1, it's gonna have to do some work. 3 times 1 plus Y, -6. In other words, 3 plus Y, -6. And you can see Y is gonna come out to be -9. I'm gonna drop my negative for a second. Now I'm gonna see if it's on there. So if I go to 1, I'll go to the right one unit, and then I'll go down how many? 9. Right on the money. There's my checkpoint. There are 2 special cases I have not warned you about yet. You of course will find them when you go to do the homework. There's a couple specialty cases that I didn't touch on today. So if you can figure them out, great. If not, just bring them your questions next time. All right, that's all I got. I'm gonna put it in your homework right now. You know you can improve your scores on the final, right? You know you can improve on the final, right?
I can prove
Look at the read the syllabus where I have the grade things. You'll see how that goes. So you can improve you can improve all your test grades.
So actually, I can somewhat like do my test over, is that what you're saying?
Well, on the final, it'll cover the same material as the 14.